All right, guys, number 20. It's going to be a percentage question. Real quick background here. When you're going up a percentage, just a reminder that what you're doing at this point is you're going to go 1 plus, and then we're going to go and add whatever that percentage is as a decimal. When you're going down a percentage, then what you're doing is you're going to go 1 minus whatever that percentage off that you have. So we're going to be using that concept on number 20. So number 20, you have Alma bought a laptop at a store that gave a 20% discount off. So when I see that 20% off, I'm looking at this scenario, and I know I'm going to be multiplying at some point in this problem by 0.80 because I went 1 minus 0.2. The total amount she paid was P dollars, including an 8% sales tax. So when I see that 8% sales tax, I know at some point I'm going to be multiplying by 1.08. So those two numbers are going to need to show up in my equation. Just seeing those numbers could help you narrow down your answer choices to, it looks like, in this case, C or D. Those are the only ones using both of those numbers, but I know they're going to show up. So which of the following represents the original price that she paid? So the original is like what it equals. So I'm going to say, all right, that original price is, I'm going to just call it X. And what you're doing to get to the amount she paid, which was P dollars, what I have to do is take this original price, and I got to do a couple things to it. First off, we're taking off 20% off that price, that original price. I'm going to multiply this number by 0.80, and that's, again, taking the 20% off. Then you go to the register and you add 8% to that cost. So I'm going to multiply that number by 1.08, and that's going to give you the amount that you ended up paying. Now in this problem, you'll see that they're all solved for P because they want the original, the equation that represents the original cost in terms of P. So all we're going to do is we're going to divide both sides by 0.80 and 1.08. And that's going to give you your answer in this one, if you can see it here. So we're looking for this expression. So if you look and you want to see that expression, that's going to be answer choice D. So that's going to be number 20. So number 20 is D. Number 21 is another probability question. I can tell that because I can see that we're dealing with a two-way frequency table. So when I see this big long paragraph and this graph, I know that most of that paragraph is just going to be explaining what that graph is telling me anyway. So I'm going to try to skip down to the actual question. In this case, the question says, if a person is chosen at random from those who recalled at least one dream. Now, when I do a probability, remember it is desired, so probability equals desired outcomes divided by total outcomes. But we need to know what that total is before I can find the desired. I need to know what group I'm pulling from. Well, in this case, I'm pulling from someone who recalled at least one dream. So if I'm looking at this chart, I'm looking at this table right here, because this is one dream, but so is this. This is at least one as well. So both of these represent at least one dream. The only ones that don't would be the nones. So from that, what is the probability that the person belonged to group Y? So as I figure this out, I might have my desired outcomes. They belong to group Y. That's going to be 11 plus 68. So that's my numerator. My denominator is the total possible outcomes from this group. So that's going to be 39 plus 125. So I'm going to add those up. So that's going to be 79. And then 125, that's going to be 164. And I'm looking for the answer that says that, which is C. Again, all it is desired outcomes divided by total possible outcomes. I always try to tell you, start here so you know what you're pulling from, and then you can pull the desired from that rather easily. So that's going to be number 21. So next up, we have number 22 and 23. They kind of go together. They have this big chart, which I can't draw up here. It's too much. but you can see it on the screen. So I'm going to kind of pull some information from that. So starting with 22, you want to see what we're pulling from. So one of the things in 22 that really gives away what we're being asked to find is the phrase average rate of change. So which of the following best approximates the average rate of change? When you see that, I want you to understand that this is a slope question, and slope is rise over run. But another way, not risen, that looks bad, just deal with it. But we have rise over run. But another way to represent rise over run, if you have multiple sets of data, would be y2 minus y1 over x2 minus x1. So we're going to want to look at it like that. The reason why I'm jumping to this explanation first is because we're dealing with a bunch of data points. We don't have a graph, so there's no rise over run defined. So which best approximates the average rate of change in the annual budget for agriculture or natural resources in Kansas from 2008 to 2010? So first off, if I look at my points, I'm going to have 2008, and I'm going to have 2010. And again, I'm trying to set up points here because I have to find a slope. I need 2 points. So those are my inputs. The outputs are going to be how much the budget was for the agriculture and natural resources. So I'm looking at that top row, the agriculture natural resources, and the first one in 2008 was 358,708. So I have that as my first output. The second one was 488,106. So those are my 2 points, and that's really what you're looking for here, is just get those 2 points, and we're just going to go y2 minus y1 over x2 minus x1. So y2 minus y1. And again, notice I'm just subtracting my 2 y values, divided by x2 minus x1. We can do this in our head. 2010 minus 2008 is 2 years. So we're going to see which one that mostly gives us. And it looks like here we get about 64,699. Now, none of those answers match perfectly, but they say which of the following best approximates. So I'm looking for an answer that's closest to this. Well, B is closest to that at 65,000. That's pretty close. So we're going to go with B, which is our answer for number 22. So then we have number 23. It says, of the following, which program's ratio? So they're telling me about a ratio, so I'm going to be doing a fraction here. Ratio of its 2007 budget to its 2010 budget is closest to the human resources program's ratio from 2007 to 2010. Now a ratio, again, is just you dividing these two things. So when they say the ratio, obviously I want to start with the ratio that I was originally given, which is the human resources ratio from 2007 to 2010. So you want to look at the chart from 2007 to 2010. I'm going to look at human resources. So the 2007 one, which is going to be my numerator, that's the first number when we do our ratio. And remember, if I say like A to B, that means A divided by B. So that's what I'm doing here. I'm just dividing the A and the B value. So the one that I was given, if you look in 2007, human resources, you're going to get 4,051,000 and 50. So I have that ratio, or that number, divided by the 2010 value for human resources, which is 5,921,000 and 379. So again, you want to get your calculator out at this point and see what you get. You're going to get approximately 0.684. So we're trying to find a ratio that comes closest to 0.684 when you divide them. So one thing you can do as you're going through your answer choices is see which ones aren't even worth considering. For example, if I find a ratio where this number is bigger on top, I know it's not going to give me 0.684. So when you look at these, if you're looking at your answers, C and D, if you look at highway and transportation, at those two numbers, those are almost the same. So I probably wouldn't check out C. If you can't really tell, then you're going to have to check each one until you find the one that's closest. But public safety is another one. That looks like it's about half, so I'm not going to consider that one as well. So again, I'm just looking at those numbers and seeing which ones might be close. And I was kind of stuck here between A and B when you're looking at agriculture, natural resources, and education. But I'll just kind of, for the sake of time, you're just going to test each one until you find the one that's closest. So when you do answer choice B, when you divide these, it's going to be, and I'll just show the right answer. I'll show you what the other ratio would be and how you compare them. But for sake of time, this would be 2,164,000. This is for answer choice B, 607, divided by 3 million. We have 8,000, so 008, and 036. Now this is going to give you approximately 0.719, not exactly 0.684, but awfully close. And when you look at A, when you divide those, that's going to approximately give you 0.766. So these are the two closest. Now again, if you can't tell, you got to test the other ones, and that's what you just do. You just go ahead and plug them into your calculator, test as quickly as you can, but you're going to end up with B being the closest number. So B is going to be your answer for 23. So that's 23. Next up, 24. Now 24 is dealing with a circle, so you have to understand the equation for a circle. So on 24, I'm going to start with that. Understand that the equation for a circle is going to be x minus h quantity squared plus y minus k quantity squared equals r squared. So we're going to need to know that for the test on multiple occasions. And again, it's not like it's tested 5, 6, 7 times on a test, but once, twice, maybe 3, usually just once or twice. You need to make sure you're prepared for that. So this one's giving you the center. So what they're doing is they're giving you h and k. So in this case, hk is equal to 0.4. So that's hk. And it has a radius with an endpoint of 4/5, 5. Now, before I go ahead and solve this, I want to show you a little shortcut. Right off the bat, I know that this is going to be x minus h. So this is going to be x squared, because h is 0. K is going to be 4, so it's going to be plus y minus 4 squared, and that equals r squared. So right off the bat, you can eliminate the answers that don't have that. So B and D are already ruled out. And also we know our answer is going to equal a squared term. So when you look at the two answer choices, A has 25/9, where B has 5/3. Well, A is 5/3 squared. So good chance that A is going to be your answer, which it is. But that's a great little shortcut. As you can see that, well, they're squaring the radius on A, and I know it should be squared, so that should probably be my answer. Now, the only other way to look at this is you can kind of go ahead and plot this and and find the radius. So in case they have two squared terms, you're not really sure which one it is. You have the 0.04, and I'm just going to do maybe a not to scale graph, but just to kind of give you an idea what's going on, and the 0.4/3, 5. So what you would do to find the radius is you just take these 2 points, you would be finding this distance, because this is the center of the circle, and that's a point on the circle. So you got a circle kind of going around here. I need to find r, which is the radius. So if you're going to do that, you would say I'm going right 4/3. I'm going up from 4 to 5, I'm going up 1. So if you wanted to find that radius, you would then go 4/3 squared plus 1 squared equals r squared. And if you do it this way, and you're solving for r, you're going to get 16/9 plus 1, which I'm going to call 9/9, because that's 1, and that's going to equal r squared. Remember, we want r squared. We don't want r. I just want to plug in r squared in my equation. So this would be 25/9. So you can find it. I just said there's a little bit of a shortcut here that helps you get there a little bit faster. So that's going to be number 24. 24 is A. And lastly, we have number 25. This one's giving me the equation. So we have h is equal to negative 4.9 t squared plus 25t. So this is giving me an equation. Now, one thing I like to talk about with standard form equations, technically there's a plus 0 here. That just tells me that I touch the y-axis at the origin at 0, so we have a y-intercept. The negative tells me that it's going to be upside down, so I can tell based off those two things, my graph roughly looks like this. It's an upside down parabola. The negative tells me it's upside down. This 0 right here tells me I have a y-intercept at 0. Those are two key features of a standard form quadratic equation that you want to know. So this equation expresses the approximate height of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. Now that in the first sentence there, all they're doing is describing the equation, and you can kind of see that picture would match a ball traveling in the air. So that's not really that important. What is important is the question says, after approximately how many seconds will the ball hit the ground? So I want to know when it hits the ground, so I want this value. I want t0. So what we're going to do is we're going to solve this. We're going to set the height equal to 0. So we're going to have 0 equals negative 4.9 t squared plus 2.5 t. And we're going to solve this quadratic equation. And how do you solve a quadratic? You factor it. It's already set equal to 0. So you set it equal to 0, you factor it, and then you set each one of those factors equal to 0. So to factor this, I'm going to pull out a t value. So this is going to be negative 4.9 t plus 2.5. Now this value I don't care about because that's going to give me t equals 0. I don't want to know when it left because I know when it left. I want to know when it hit the ground. So in this case, I'm just going to take this factor and set that equal to 0. So negative 4.9 t plus 2.5 equals 0. So that's negative 4.9 t equals negative 2.5. You'll notice those negatives are going to cancel out. So we're going to divide by negative 4.9 on both sides. And t, in this case, is going to divide out to be about 5.1. So we're looking to know when it hits the ground, and it says after approximately how many seconds. 5.1 is approximately 5, so your answer here is going to be D. So that's going to be number 25.